Hope you guys are all doing well today. This is my husband.
Hello.
I had a question for you.
Okay.
Do you remember when we made that video like 2 years ago in our kitchen
Yes, I
with
do.
with the chemistry vials and the different substances?
Yes.
Yeah. Well, today, guys, I am actually going to have you watch a retro video. It was one of the very first videos that I ever made with my flipped classroom, and my husband was in it. And so this is an oldie but a goodie, and it's going to give you an overview of what you're going to do in your lab. So let's check it out. Do you want to say goodbye?
Bye, kids.
Can I tell you a little bit about what we've been doing in class?
Let's hear it.
Okay, well, the kids have been learning about chemistry. And they've got to deal with mysterious substances, crazy things like sodium bicarbonate, sodium bicarbonate, and citric acid. Do you know what? Have you used any of these before, honey?
They look familiar. The kitchen.
In the kitchen, yes. Sodium bicarbonate is just baking soda.
Baking soda.
But citric acid, that you can find in more foods.
Oranges.
Yes, like oranges. Very good. But oh, look who's here. Should we show him who's here?
Oh, we got a visitor.
Say hi, Phil. That's Phil. Phil is our kitty. Okay, so what we're going to do is I'm going to show you what happens when we put both of them together. What do you think is going to happen?
It's gonna bubble.
It's going to bubble? Why do you think it's going to bubble?
It's gonna be a reaction.
It's going to be a reaction. Why do you think that?
That's what chemicals do when you put them together.
That's what chemicals do when you put them together. That's often the case. I'm glad you didn't say that you thought it was going to start on fire.
I don't think so.
Okay. So I'm putting in 1 scoop of citric acid and 1 scoop of sodium bicarbonate. I'm using the bigger spoon. This spoon is a 2 milliliter spoon. And I'm putting them in this clear cup so I can show Bob the reaction. Oh boy, Phil is very interested in this. I think he's going to jump in front of the camera. Phil.
Come over here. Get out of the way.
Phil, I'm glad you want to learn, Phil, but...
Get down.
Okay, so I have 5 milliliters of water in this. And here is what happens.
Whoa.
So what happened?
Looks like a soda pop.
Kind of looks like soda pop, doesn't it?
Looks like a can of soda you just shook up. It had a reaction.
There's a reaction. And how do we know there's a reaction?
I can see the bubbles.
You can see the bubbles. Okay. Do you know what bubbles mean when it happens in a reaction?
Bubbles give off gas.
Bubbles give off gas. Very good. Now, do you know what kind of gas this is?
No, I don't.
Well, if we have carbon and hydrogen and oxygen in this element, and sodium, hydrogen, carbon, and oxygen in this element, we're going to learn a little bit later about the specifics, but this gas is just carbon dioxide. So it's okay that we're breathing it.
Well, that's good. Carbon dioxide.
Carbon dioxide.
Okay.
So my kids actually studied what this looks like, but they studied it, and some of them evaporated the water out, and they did different things to look at this reaction more carefully. But there's actually another part of the reaction that we could look at.
Okay.
And we could look at the gas. But how in the world do you study something that you can't see?
You gotta trap it.
You gotta trap it somehow.
You gotta collect it somehow.
And do you have any ideas about how we could collect it?
Not out of something that size.
Not
out of a cup.
Not out of a cup.
I don't know how you trap it in there.
Okay. Well, what if we had something else? What if we had a bottle that looked like this?
That would work.
Okay, how could we trap it in there?
You could probably use a balloon.
We could use a balloon. Okay. Well, here is a balloon, and
Okay.
here is a stopper. We could put the stopper fits, just fits in the top of it. We could put the balloon over the stopper.
Okay.
And then we'll put this on real fast after we put our ingredients together. What do you think about that?
Sounds good. That should work.
All right, let's try it. Do you want to be in charge of the balloon, or do you want to be in charge of the ingredients?
I'll be in charge of the balloon.
Okay. So I'm going to put a scoop of citric acid. Do you know I'm being a bad teacher?
Why?
Because we're not wearing safety goggles.
It's good.
So
good
don't
point.
don't put your eyes over this right now, okay?
It's a good thing it's good to breathe in.
Good thing it's just carbon dioxide. Okay, so I got a scoop of citric acid and I got a scoop of sodium bicarbonate.
Okay.
And then we got to add water to it. I'll do the same thing as before. We'll do 5 milliliters. Okay? So I'm going to shoot this in there, and you need to put that on there as fast as you can, okay?
Okay.
Are you ready?
I'm ready.
1, 2, 3. Okay, what's happening?
It's definitely collecting it.
Definitely collecting the gas. We see the balloon getting bigger.
That's working.
It's working pretty good. Do you think that that's the best that we could do?
Probably not the best.
How come?
How do we know that we've trapped it all?
I don't know.
There's a lot of space in the bottle yet.
There is a lot of space in the bottle.
Yeah.
And were you the fastest that you possibly could be of putting that on there?
No, I kind of missed a little bit.
You kind of missed a little bit.
Depth perception's off.
And that's okay. Okay, so we have the gas in here. Okay, the balloon's blowed up. Now what do we do with it? What could we do? How could we actually measure this?
I don't know.
I don't know either. It's kind of hard when it's just in a balloon like this. Although we can see it, we can't really measure it. Okay? So what I'm going to have the kids do is use a syringe. The syringe has measurements on it, like this, okay, that could tell us exactly how much gas is collected.
Okay.
Okay? Well, thanks for your assistance, husband.
No problem.
You want to say goodbye to the kids and I'll tell them about the rest of their lab?
Sounds good. See you, kids. Go Cyclones.
So I hope you enjoyed that oldie but goodie of what we're going to be doing with this lab. My last hints for you with this is that you're going to click through the rest of the slides of this presentation to be able to learn what the procedure is and expectations for this lab. I have 2 hints when we going forward with this lab of capturing gas. You guys are going to be using a glass bottle and you're going to be using a syringe with markings on it. What I recommend, and this often happens with groups, is I would recommend having one person in the group hold the syringe and the glass bottle, one hand on syringe, one hand on the glass bottle. And then have another person in the group use a 1-finger push down to press the stopper plunger down into there to release the liquid into the glass bottle to make the reaction start. The reason that you have the one person holding the syringe and the bottle is because there's a lot of pressure created from this reaction, and what often happens is there's a pop-off because of the pressure. And if that does pop, you will not get an accurate reading with your gas that's created in the syringe. And so what you're going to need to do is you want to have one person hold the syringe and bottle system like this, while another person presses the stopper down. So continue to click through the rest of the slides to understand the whole lab, and as soon as you get started, or as soon as you walk into class, you'll be able to get started with the lab. So I'll see you later.